So this is a pretty typical problem for 6.5, is just to graph the transformation of secant, for instance. On my math lab, they're going to give you multiple choice for this, and they're pretty easy to get right just by guessing 2 or 3 times and hitting similar problem if you need to and guessing a few more times. I would encourage you to make sure that you can get problems right by not just by guessing, because on the activities and on the final exam, when that rolls around, you will need to be able to just graph a transformation like we're about to do here by hand. And if you can do that, then you really understand what's going on. So keep in mind that secant, secant is the same thing as 1 over cosine. So one way to do these transformations is to graph the transformed cosine function first, and that's the approach that I'm going to take. So let's pretend this isn't secant, but let's pretend it's cosine, and then we'll get secant just by bouncing off of that. So let's talk about there's no change to the amplitude. Amplitude is still just 1, but there's period and there's vertical shift changes. So let's talk about the period. And we know that the period is 2 pi divided by the omega. For us, that would be 2 pi divided by 2 pi over 3. So flip that 2 pi over 3 on the bottom, flip it over and multiply. The 2 pi's cancel, and the period ends up just being 3. So we have a period of 3. We also have a vertical shift of 3. So let's work on graphing a cosine function that has a period of 3 and a vertical shift of 3. So if it has a vertical shift of 3, its center line will be 3, and instead of going, well, it still goes up 1, so it'll go up to a height of 4 and down to a height of 2. And this will also, since it has a period of 3, go out 0, 1, 2, go out about 3 there. So the graph of cosine starts up and goes down through the middle and comes around and comes back up. Okay, so that would be cosine. Secant, on the other hand, just kind of bounces off of that. So secant would look like that, and like this, and it continues on. Of course, if you want to, you can keep going. And same thing over here. It continues on over there. And the asymptotes, asymptote would be there. And another asymptote there. So if you want to figure out where those asymptotes are, keep in mind the start of my period was 0, end of my period was 3. That means right here in the middle of this loop, that is 3/2, halfway through the period. And the asymptotes occur halfway through this part. So halfway between 0 and 3/2 is 3/4. So maybe I'll label it down here, 3/4. And halfway between 3/4 and 3. And if the halfway over between is difficult, it's the average of the two. So you add them together and divide by 2. So you could think of this as 3/2 plus 6/2 is 9/2, and half of that is 9/4. Okay, so that's where the two asymptotes are at. So there's a pretty good little sketch of one period of this transformed secant function. We also wanted to talk about the domain and the range. So let's talk about domain. And the domain is everywhere except these asymptotes. Those are the places where you can't plug in an x value and get a value of the secant graph. So the domain is all x except 3/4 and 9/4. And sometimes they just ask for the domain in one period. But if you need to keep going, the pattern's the same. So notice it's 3/4 plus 6/4 would get you to 9/4. Plus 6, the next asymptote would be at 15/4. Plus 6, the next asymptote would be at 21/4. And so on. And the range, finally, notice that the range, so this is an asymptote, so this function goes all the way down, goes all the way up. It covers all of the range except for this little chunk here in the middle that happens to be exactly the green graph. So it covers everything except for the space between 2 and 4. So the range will be all y values except that space between 2 and 4. And notice when I'm saying except that, I'm leaving 2 is part of the range and 4 is part of the range. So it's everything except the space between 2 and 4. So you can write it that way. You can also say the range would be negative infinity up to and including, so including is the square bracket, negative infinity up to and including 2. Then there's that open space, but that's joined with or union with the space from 4 up to positive infinity. And keep in mind, infinity is not a number. We don't ever actually get to it, so we always have round brackets on the infinities to say we're not actually getting there. But the 4 and the 2 are part of the range, so we do want to include them using square brackets.